let me inch the dipole here. So let me bring that inch. It'll be easy for you. Okay, there's a A, there's a B. Anything will happen to this dipole. So they're having a charge Q and mass M. The positive charge in what direction will experience a force? In the direction of field. And the negative charge will experience force opposite to the field. So let me take, this is L, this is L, this is QE, this is QE. Is there any torque acting on it? The inch, let me show in this way, you'll get confused. Okay, O is an inch, I'll put it. There's a light rod. What is AB? AB is a light rod. AB is a light rod. I want torque. See, you know enough rotation mechanics. There's no second thought for you. Directly get into the mathematics, you know it, the torque, all that one. Don't bother about electrostatics here, nothing to do. What is, let me bring this theta. Shall we go for torque acting on the system? The total resultant torque should be equal to OA bar cross QE bar, R bar cross F bar, then similarly plus OB bar cross QE bar, or F plus will write time being. F minus bar. No, this will be in what action it should be? QE bar, OB bar cross. This let me increase the nib. Yeah. What is F minus? F minus should be equal to minus of QE bar. See, E bar will be directed towards right. This force, how it is acting? This force is towards left, no? So minus of QE bar, I'll write it here. So this will become OA bar cross QE bar OB bar. So this minus of OB bar, let me adjust the negative sign for this, into QE bar. Then this will become OA bar cross QE bar. OB bar, shall I write it as minus OB bar as BO bar? BO bar plus OA bar cross QE bar. Now what is BO bar plus OA bar? Should be equal to BA bar. This Q, let me adjust to this. Q into BA bar cross E bar. This is the resultant torque. What is BA bar? Is the length. And what is Q charge? And shall we call this as dipole moment? So if a point charge, if a dipole is kept in an uniform electric field, what is the torque acting on it? So what is the method? You should go for the force acting on individual charge particle, then you should find out the distance R bar. Every time, instead of doing this maths, we have brought a one very generalized formula. We know what is a dipole. It is expressed by its dipole moment. And I know the orientation of dipole, how the dipole moment is directed here. It will be directed in this way. Do I know the orientation of electric field is? Just by taking help of this formula, I can say no, whether is there any torque acting on the dipole or not. This will be a better approach rather than fighting with this method. Now this will be the magnitude is given by PE sin theta. You know torque. What is the theta now? Angle between the dipole moment and the electric field strength vector. Similarly, is there any interaction between the point charge and the field? Yes, there is interaction. So then we have a formula, interaction, there's a torque. Acting on a dipole kept in an external field. What is that E bar? E bar is an external field. This is the external field. Who will produce? Non-conducting charge sheet or some charged body, let's not bother. In that particular external field, I am going to bring a dipole. Got the idea, no? Similarly, now, is there any interaction between the dipole and the electric field? There's interaction because you can see the forces are acting. Definitely, there is some energy associated. So what is the interaction potential G? Between dipole and external field. It is given by U equal to minus P bar dot E bar. Or if you expand it, PE cos theta. I'm telling this one, if you want to study the insulators only through dipole, because every insulator, any sub insulators, I assume insulators to be made up of atoms. And that atom, I am going to assume it to be made up of dipoles. So without the knowledge of dipoles, you can never study the insulator. I think in chemistry, you do have some conducting liquids, non-conducting liquids. How you are going to study the chemical reaction with non-conducting through dipole moment only. So therefore, this is very much essential. It's for physics, it's in just solving numerical. In chemistry, no, this is the most essential parameter. Dipole moment of a molecule. Yes, one must have that one. A thorough knowledge of this is needed. Of course, chemistry teachers cannot explain this. Okay, in physics, we are explaining how to calculate the dipole moment, what is the equilibrium, all that one. So every reaction, not just only chemistry, maths will be involved, statistics, probability, geometry, the physics, so many things will be involved. A dynamic approach for chemistry will come when you start applying the all other fields, not only just chemistry. That's what the way of learning chemistry. Maybe at a higher level, you are going to develop this particular approach. So every atom for you, what happens is like a now dipole. Fine. So this is about the interaction potential. Okay, now with the help of